Why don't we put solar panels directly on electric cars? If you can power your entire house with solar panels, why can't you power your car with solar panels? Even if you can't get infinite range, surely you could increase the range, right? I think from a very practical standpoint, there are a lot of reasons to think this should already be a thing. First, at least in prototype form, we've seen concepts of these types of cars actually operating for very long distances. You only have to travel to Australia and visit something called the World Solar Challenge. Every other year, they have a competition with lots of cars from colleges all over the world, cars that are specifically designed to run exclusively on solar. And that World Solar Challenge, that's been going on since the 1980s. Over 30 years of competition and development, and we still haven't seen one of those vehicles transition into something that is a consumer-ready car. Number two, there's a huge profit incentive here. If you could produce a car with unlimited range, who wouldn't want to purchase such a car? And even if it just had extended range, the fuel savings alone would also be a huge motivation to purchase such a car. Pretty much every developed country will be offering financial incentives in the form of tax breaks and rebates for purchasing these cars. And finally, it's not for a lack of trying. Two companies have gone bankrupt trying to develop a solar-powered car. Why is this so hard? That's the thing that's so exciting to me about this particular topic, because like everything else in engineering, there is a trade-off. There are huge differences in the vehicles that we see in the World Solar Challenge and the kind of vehicle that a consumer wants to drive on the road. So today we're going to take a look at what those challenges are and also take a snapshot of where we are today in terms of seeing a commercially viable solar-powered car on the road. Let's get started. Now, the solar panel itself is a really ingenious device, and I don't want to go through all of the details of how it works because there's a really fantastic video about that already on YouTube. The video is made by a channel called The Engineering Mindset, and he goes through the whole process of how photons hit the surface of the solar panel, break off electrons, and how that turns into electricity flowing through a circuit. So I'm going to put a link to that video in the description. For the purposes of this video, we're just going to say that a solar panel is a device that converts solar energy into electrical energy in real time, and it's directly proportional to the sunlight. So let me show you what I mean. So right now we have roughly 3.8 volts just from the ambient light in this room. And if I use a more concentrated light source, which I have right here, I can bump that number up to 4.8, 4.9 volts. If we have a very cloudy day like this, the voltage drops. Some of the light is penetrating the paper and still causing electricity to flow through the solar panel. If I completely obscure this with something that light can't penetrate, my hand, you can see the voltage is negligible, it's almost zero. There's one more thing I want to say about panels before we explore this idea further, is you can stack them like batteries. So here I've got two panels. I've connected them in series, which means that the electricity from the first one has to flow through the second one. With the solar panels stacked, you can see that the voltage is higher. And just like before, if I add some concentrated light, the voltage goes up even more. This means that we can be clever with the way that we arrange our solar panels to get exactly the right voltage that we want, as well as the right amount of current. So let's review the two things we've learned so far, because this kind of sets the pace for every other problem we're going to run into. Number one, your solar panels only produce power in direct proportion to the amount of sunlight that they get. So if it's a cloudy day, you've got less power. If it's at night, you have zero power. If you are parked in a garage, you have zero power. If you are parked under a tree, you've got less power. If you're parked behind a tractor trailer truck that's blocking all the sunlight, you have even less power. Once you start to consider all the scenarios where your car is going to be getting less sunlight, like during the wintertime when the days are shorter, any place that has a high concentration of people and thus a high concentration of cars will also have a high concentration of big buildings, because people tend to come together and work in these big buildings or live in tall apartment buildings. All of this means more shaded spots covering your car from the sunlight. And that means we not only need a battery for the times that we don't have any power available, for example, driving at night, we also need to maximize the amount of charging when we do have light. And that brings us to the second thing, which is increasing the number of solar panels will increase the amount of energy we can absorb from the sun when we do have sunlight available. And that brings up some other interesting things, like the shape of the car is not exactly optimized for solar panels. You can see this is all curved and sexy, and we love our curves on the car, not just because of the way it looks, but also because of the aerodynamics of the car. Having a sleeker, more aerodynamic car means that you can drive more miles on the same amount of energy, fuel in terms of a gasoline car, and with an electric car, the same thing, less power used. You can make curved solar panels, they get more expensive. There are other trade-offs, which we may not cover in this video. But for now, we need to make this a heck of a lot uglier and something that's a little bit more conducive to flat rectangular solar panels. So it's not gonna be as sexy as this, but if we make our car kind of blocky, rectangular-ish, maybe people will buy it because we can drive on solar, right? All right, so here we have my blocky, more solar optimized vehicle shape here. And to explain what's going on the inside, well, you can't really see that because it's all taped up. But basically what I did was wire the panels in series across here, and then all along here, they're wired in parallel. And that'll give me the maximum current flow. All right, it looks like I'm not gonna be able to do the experiment I wanted to do because these panels don't put out nearly the power that they claimed on their website. I had done the math and figured out how to power these wheels for the experiment, but it's all good. I'm not mad that I spent all this time 3D printing, soldering, and making this car for it to not work. It's all good. Anyway, we can still drive home a few key points here. Number one, even with the ambient light in the room, we've got a little over 7 volts here. If I give myself a brighter, more direct sunlight, you can see I can influence the power available quite a bit, right? And the point I really want to drive home is this is heavily weather dependent. As the sun moves over to the side of the vehicle, wow, that voltage is almost gone, right? Given these limitations, the temptation is to cover every square inch of the vehicle with solar panels. And in fact, this is what we see in the World Solar Challenge. Every square inch of the vehicle that might get sunlight has a solar panel on it. But this comes with some huge trade-offs. The first one being you are greatly increasing the cost, and you're putting the solar panels in a position where they're not gonna be very efficient. The ones on the door, and especially ones that you put on bumpers, will all be pointed in the wrong direction. When we put solar panels on a home, a lot of care is put into thinking about which side of the roof to put them on and what angle to tilt them at to get the maximum amount of sunlight. And what they do in the solar power challenge is they actually pull over every once in a while, lift up the hood, and expose all the solar panels at just the right angle to get the maximum amount of sunlight. Well, we're gonna assume that consumers aren't willing to do that. And if I live in a big city, my car's parked in a garage and none of that matters. Also, you are removing structural material from the car, and these vehicles have to be crash-worthy. So everywhere that you install a panel, let's say in the door in this example, that door, when it gets hit by another vehicle, because it will happen eventually, it may not happen to you, but it will happen to someone driving this type of vehicle. These doors need to be able to handle a collision with another car. I also don't think it's smart to put solar panels in areas like where your bumper should be, because these are areas that are very likely to be involved in fender benders and will significantly increase the cost of insurance and repairing your car without giving you a whole lot of energy benefit in the trade-off. So it looks like we're a little bit limited in the surface area problem and the orientation problem, but that's not the end of our troubles. The solar panels themselves aren't that efficient. Today's consumer-grade solar panels still only get you about 15 to 20% efficiency, with the best ones being closer to 22%. And if you happen to have $100,000 or more lying around, you can use gallium arsenide, which is the kind of solar panel that's used for space missions, and even some of the solar power challenge teams will use these special solar panels, getting you closer to 30%. Finally, the best solar panels in the world, not available to the public, still in the research phase, are getting somewhere around 47, 48% efficiency. So there's definitely some cool technology in the pipelines. Surely those technologies will get cheaper in the future, but for now, I think it's safe to say that we still have many years before we reach that point, and the typical consumer, even in the wealthiest countries, are not gonna pay $100,000 just for the solar panels in order to have a solar powered car. It simply isn't worth the fuel savings. And even if it was worth the fuel savings, People just can't afford to pay that much for their vehicle. Now that I have thoroughly disappointed you, I want to say that's not the end of the story. There are more things to consider here. Given the limitations of the solar panels and the limits of the available space, we are a little bit capped on the amount of energy that we can capture from the sun, at least in the short term. So the flip side of this coin is reducing the amount of energy that we use in order to do our daily driving. Well, there are two areas that we can approach there. Number one, we can make everybody drive slower. If you reduce the acceleration capacity of the car and the top speed, both of those variables will reduce the amount of energy that the car uses. Consumers aren't going to love this, and you're not going to, sell somebody a sports car with a top speed of 50 miles an hour. But I just thought it was worth mentioning that your driving behavior has a huge influence on the amount of energy that you use. This applies to solar. This also applies to your fuel car. Now, there is one huge advantage that electric vehicles have over their gasoline counterparts, and that is the electric motor can actually be used as a generator when you want to stop the vehicle. Let me explain what that means. Right now, if you take an electric motor, and this works with almost every type of electric motor, the electricity is normally used to drive the shaft, right? So if we supply electricity to this shaft, it will make the motor, or it'll make the wheel spin. But this also works in reverse. If I want to spin this shaft, as I'm doing here, I can actually get electricity on the wires. You have to spin it pretty hard. It takes effort. There's mechanical input going in and electricity coming out, right? If I take these wires and hook this up to a battery, I will actually charge the battery. Now, here's where things get interesting. As you start producing electricity on these wires, the amount of electricity flowing here is directly proportional to the difficulty of spinning this shaft. In other words, producing electricity this way makes the wheel turn into a brake. So if you want to stop the car, you just switch your electric motor into a generator. This will create a braking action on the wheel, making it want to stop spinning. And instead of heating up brake pads and wasting all that energy as heat, you actually get a little bit of a charge on the car. Now, I want to be really clear that this is not free energy. I get hundreds of emails from people saying, Jeremy, why don't we add an alternator to an electric car? Wouldn't you be able to collect all the motion of the car as energy, and you could be constantly charging? So as long as you're driving, you're charging the battery, you could drive forever or increase the range. But that's not how it works. The kinetic energy of the car is being given up in exchange for electricity. Instead of using the motor, if we take an alternator and attach it to the wheel, attach it to the drive shaft, to any motion in the car, it's going to act like a brake on that moving part of the car. In direct proportion to how much energy you get, electrical energy you get, the car will slow down. If you were traveling at 50 miles an hour down the highway, remember that energy to maintain your 50 miles an hour is being supplied by the electric motor via the battery. So the battery is being drained during that process. And you know this is happening because if you take your foot off of the accelerator, the car immediately slows down. If you put an additional load on that motor, in this case, you add a brake to the wheel, which makes it really hard to turn this wheel, you've made it more difficult to maintain your 50 miles an hour. So now your electric motor has to push harder to maintain your 50 miles an hour, and thus is going to draw more power from the battery. And the power that's being drawn for the battery to meet that load is always more than what your alternator can give back, because the alternator is wasting a lot of power in between. Sometimes I make the analogy this way. I'll say adding an alternator to your car is like buying a cash machine that gives you $20 in exchange for $50. Yes, it gives you money, but it gives you far less money than what you had to put into it to get money out of it. And thus, you shouldn't buy the machine. It doesn't make sense. The same thing here. The electricity required from the battery that transferred through the motor to the alternator, it's being transformed through all these processes, wasting a lot of the energy, and you get a small amount back. It's simply not worth it. Not while you're driving down a highway, but since we actually want to use up the kinetic energy of the car, we actually want to stop the car, this is a genius idea, and it's called regenerative braking. Instead of what we do in gasoline cars, where we just grab the wheel with a disc and turn all the kinetic energy of the car into heat on the brake pads, we can actually turn that back into some useful energy. So some energy that was being wasted is being recaptured. but you can't capture energy that was never supplied. And in this case, trying to drive infinitely on a alternator connected to your drivetrain, your motor, your wheels, anywhere, you will be wasting more energy than you can get back. And thus, nobody does it. Everything else that I'm about to say applies to gasoline cars as well as electric vehicles. The other variable that we need to consider, in fact, the one that I think is by far the deciding factor for the future of solar-powered cars, and that is the total weight of the car. Other than speed, if we can reduce the weight of this vehicle, we will greatly improve the fuel efficiency of these vehicles. But there's a catch. Automakers have already been thinking about this for a long time. The same things that make electric cars more efficient will also make fuel-powered cars more efficient. So automakers have already considered variables like making the car smaller, making the components out of lighter materials when possible, but that doesn't mean we can't do better. Automakers are continually looking for ways to reduce the weight of their vehicles. New materials are being developed all the time, and materials that have historically been expensive, like carbon fiber, as we improve the labor-intensive manufacturing part of making a part out of carbon fiber, it'll reduce the cost. The limitations really come from the consumer, right? A soccer mom is not going to want to drive a little tiny vehicle. She needs a place to put her kid in the back. So when you look at these vehicles in the solar power challenge, where there's no air conditioner, there's one driver inside the vehicle and he's in this tiny little bubble. Even if you commute to work every day by yourself, you are not going to want to sit in that steaming, hot, claustrophobic box to drive to work every day. Consumers vote with their dollars. You might say that you want a solar powered car, but what you really want is all of the creature comforts that you have now and solar. You don't just want a solar car. You wouldn't be willing to give up your air conditioning and your space inside of the vehicle. So we're going to have some space available. We're going to need cup holders. People want to eat in their car. These are all things that we need to consider when designing the solar powered cars of the future. Speaking of design, there's a couple basic elements that are surprisingly important when designing a product for consumers, but they're easy to forget. Number one, you should not expect people to pay more for fewer features. It doesn't matter how great you think your solar powered car is, there are some features that people have become accustomed to expecting when purchasing a car, like a place to put their drink, stereo, air conditioning. These features need to be there and it can't increase the cost of the vehicle. Related to that, you shouldn't expect people to change their behavior. Even if your new design makes their life easier in your mind, you need to be really sure that that's both communicated well and that it requires almost no training to adapt to this new method or approach. If your design requires more work and there's still competition, you are pretty much destined to fail. People don't want to work harder for the same thing. And I also wouldn't expect the consumer to drive any slower, even though that's known to give you more fuel efficiency. If they had a lead foot before they bought this solar powered car, they will continue to have a lead foot when they start driving this solar powered car. I would not expect my consumer to pull over and raise up their hood or do anything special with their car. They just want to get out of their car and go to work. But there's an interesting related problem to this, and that is people will tell you they want this feature. And there are indeed some hardcore people who will be willing to pull over, lift their hood up and do the work to gain a few extra miles of traveling distance a day. But what I think will happen with the vast majority of users is they will simply wait until they get home and plug in their car like many other electric cars are currently. So maybe if you're really sure people want this, you could introduce it as an add-on, but not a default feature. When faced with the choice between a more expensive car with a feature they don't use and something that's more affordable, people will vote with their dollars for the more affordable vehicle, despite what they told you they wanted. One of my favorite examples of this is I had a client who owned a series of hamburger chains. I won't say which chain it was. They didn't have a chicken sandwich on the menu. They wanted to add some sort of grilled, healthy something. So they did this big survey. A lot of people said, yes, I would buy a chicken sandwich if you offered it. And they went through with it. They added this thing to the menu. Less than 1% of the sales came from the chicken sandwich. And my client was lamenting the fact that it cost them so much to keep this grilled chicken fresh and the whole process that they went through to try to make this thing both taste good and be on the menu. It could not compete with those juicy hamburgers that they were selling, and people just didn't buy it even though they said they wanted to buy it. That means you can't trust people to tell you how they will vote with their dollars. Surveys will let you down. I know how terrible that sounds, but it's just the truth. It's not that they want to lie to you, it's just that they don't know how they will actually behave when put in that situation. They can only tell you how they hope they will behave, how their ideal self would behave in that situation. In this case, they all thought that they wanted to pick the healthier option, but when put right next to a juicy hamburger, they chose the hamburger. And so what I would recommend as a designer is that if at all possible, you get some kind of prototype in the person's hands so that you can see their real behavior. Don't tell them what to expect. Just watch them and see how they behave. This is where you're going to get the best possible feedback. This is difficult. It takes way more effort and energy, but it's worth it. By far the best part of my job in engineering is thinking about these kinds of problems. I love the constant trade-off of thinking about it can only weigh so much, it can only cost so much. You know, consumers will want these various features. And if you want to develop solutions in a cost-effective way, you have to be able to do so quickly. Otherwise, you spend more time thinking about the tool than you do actually the solution that you want to create. For me, those tools are things like SolidWorks, and you should be able to do that without thinking about it. The same way that you get in your car and just drive to work, you don't think about how to operate the car, you just think about you only use the car as a tool to get to work, which is why I have so many videos about how to use motors in various types of projects, whether it's a DIY project or an engineered solution. And also, I've done tutorials on SolidWorks because I want you to get so good at those tools that they become just second nature. They blend into you instead of being something you have to invest a lot of energy in using. It becomes a thing that makes you faster and better at the solution creating, as opposed to this stumbling block that you invest a lot of time in figuring out how to use. But then recently I ran into my friend Ryan, who happens to run the YouTube channel SolidWorks with Ryan. And it turns out we have very similar visions about sharing these tools with other people. So we're gonna be working together on some projects, and I wanted to share with you some resources he already has available over on his website. Right now, you can go over there and take a SolidWorks course with him where he will take you through from the very beginning. You know nothing about SolidWorks, how to use the interface, all the way up to the part where SolidWorks becomes completely invisible and you can just focus on the solution. I have been through this course, and I can tell you, not only will it make you better at SolidWorks, it'll increase your confidence, your speed, and it'll make you the go-to person for SolidWorks at your job. Best of all, when you finish this course, you'll be ready to sit for your CSWP, which is a certification exam, a pretty challenging one for SolidWorks professionals. If you're looking for a job in design, this is definitely something you want to be able to put on your resume. But even if you're just a hobbyist and you want to level up your skills so that you can just focus on solutions and not invest a lot of time in thinking about what tool to use where, I can't recommend this course enough. And hopefully in the near future, you'll also see some courses there from me directly. The layout of the course is perfectly logical. The customer service is fantastic. It's like a 30-day money-back guarantee. If you have any questions, they respond within a day. I was really impressed with the follow-through in making sure that everyone is happy and successful. He's not just trying to help people take a course. He is trying to help these people be successful in their careers. And that's why I wanted to work with them. So anyway, I'm going to put a link in the description for you so that you can go check that out and see the details. But if you're serious about leveling up your skills to the point that SolidWorks becomes transparent, this is the place that you want to look. My goal in this video was just to give you a deeper appreciation for just how difficult this problem really is. And I also wanted to remind you of things that we easily forget about, like safety requirements and creature comforts that consumers want. Now, I would have failed to do my job if I didn't mention that several companies in the past year have mentioned that they will be implementing solar panels in their vehicles. These solar panels in most cases are optional, and the cars still need to be plugged in. You're not totally relying on solar, but it's a step in the right direction, right? You can gain a few miles a day, in some cases a little more than that, if you leave your car parked in the sun. So I'm gonna leave some articles for you down in the description. Now, there's a whole bunch more to say, but that's why we have the comment section. So let's continue the conversation down in the comment section, and I'll talk to you there. Thanks for watching.